Hey everyone, and sorry that my toolbar is there. Sorry. Welcome back to part two of chapter two on research and the value of a um, scientific research perspective on gathering information and conclusions about the world. In this part two, we're going to be discussing um, the different methods by which academic and research material are published and disseminated. We talked a little bit in chapter one about the peer review process. What we're going to really talk about here are the different types of publications, the different places where you will find academic and research material, and then how you can get access to them, as well as other sources of information, such as wikis or the news media. So, first, we have like a little decision tree um, for tracking the sources of a claim, or maybe not sources. Sources might not be the best word. Maybe the type of reasoning behind a claim. So we can make a claim that's based on experience, which we saw we don't want. We don't like those. They have confounds and they have no comparison group. You can make a claim based on intuition, which we don't want. We don't like, for the reasons we discussed in part one. There can be a claim based on authority from an authority figure. This could be good, right? There are situations in which we like those types of claims, but it's because they're based on that authority figure's research or their knowledge of other people's research. We don't want to believe or to hold up claims from authority that are based on experience or intuition, or basically not based on research. However, then we have a whole series of research-based claims. Research claims can come from scientific sources, and we'll discuss the various types of those scientific sources here. And research claims can come from non-scientific sources, basically journalists, magazines, wikis, those sorts of things. So let's start with scientific sources. The first and foremost place, as we discussed in chapter one, where you will find published scientific material are journal articles. This is psychology as well as the rest of the science's most important source of information. This is where you publish research findings. We call those empirical journal articles. An empirical journal article is the publication of a single or maybe a set of individual experiments that were done by a scientist or group of scientists. So when we say the word empirical, we mean research. Empirical journal articles is the publication of research. However, journals will also publish what are known as review articles. Now, a review article is more about taking a step back, taking a broad perspective on a topic, and drawing some theoretical or large conclusions based upon a collection of published empirical articles. So, for example, let's say you're a developmental psychologist who studies the way in which the way in which bilingual children learn and use language, right? That's your area of study. Early bilingual language development. You, along with a host of other people, will be publishing individual experiments on bilingual language development. Then maybe every few years, you look around and you decide, okay, we've had 40 experiments, 50 experiments published on bilingual language development in the last 4 years. it's time that we take a step back and we sort of assess the lay of the land. What have we learned, right? What broad, large conclusions can we draw? Have we Do we need to develop new theories? Do we need to support certain theories? Do we need to move away from other theories? This is a review journal article would sort of be like the forest, whereas an empirical journal article are the individual trees. So we want to publish, we want to plant the individual trees, and then every once in a while we want to take a step back and look at the forest and assess how the forest is doing. So that's sort of what a good analogy for the relationship between an empirical research article and a review or maybe theoretical or conclusion based article. You'll also find published scientific material in books. So these are scientific books that are meant for consumption by other scientists. So even though they're books, they are not written for a general public audience. You can't really buy these books at Barnes and Noble or Target or Walmart. These are usually purchased by individual scientists, by departments, by universities, by libraries, institutions like that, so that they can have copies on hand for people to refer to when they want to investigate a particular phenomena. One style of scientific book is called an edited volume. So an edited volume you can think about as a series of experts, each writing a single chapter on their really specific area of expertise. And then each of those chapters written by an expert builds up to a volume, right? A larger sort of publication about a broad topic. So let's keep our example of bilingual language development. So maybe I'm a leader in the field, and I say, we really need we've been doing these review articles that look at the forest, but we need to take an even further step back, and we need to look at the continent, right? We need to go even bigger. We need a much larger scale sort of encapsulation of this topic. So I'm going to edit an edited volume on bilingual language development. And I am going to invite 20 experts in the field to write a chapter, right? So anywhere from 20 to 30 to 40 pages on their little sliver of expertise on bilingual language development. And those slivers of expertise can get really, really specific. You could imagine that there's an expert on the learning of verbs, right? And the distinguishing between verbs in bilingual children. There might be someone who's an expert on bilingual language learning in infancy, right? How infants pay attention differently to different languages. Then there might be an expert on toddlers or early childhood, and then there might be an expert on middle childhood, and then there might be an expert on bilingualism in mixed race households. There might be an expert on bilingualism in low income versus high income households. There might be an expert on bilingualism in immigrant populations, right? Because bilingual language development is very different when you're learning a second language because you're an immigrant to a new country, rather than maybe having parents who speak different languages, right? So we can break down bilingual language development into these really narrow areas of expertise, have experts write a chapter on their narrow area of expertise, and when we take a step back, we have this really complete, almost encyclopedic publication on bilingual language development. And that's happening all the time with many topics, right? That's happening with memory. That's happening with social psychology. That's happening with health psychology. And so every so often you get a new edited volume on this particular topic. You can also have full-length books, meaning a full front cover to back cover book written by the same authors, maybe one author or a group of authors. This is often done when maybe a incredibly influential or a new or an exciting maybe theory or theoretical perspective comes out, and the people who are proponents of that perspective, or maybe who sort of invented that new theoretical perspective, want to sort of announce it to the world. They want to show why it's important and how it's important, and so they might write a book. Again, this is not a book that's meant for consumption by the general population. It's going to be used by professionals. It's going to be in libraries. It might be assigned. These things are often assigned as reading material in graduate level courses because it allows the graduate student to get a really large and complete understanding about a particular topic. Now, where do you go to find these scientific sources? Unfortunately, much of our scientific information and publications are behind publisher paywalls. There are a few large, major for-profit publishers that manage much of scientific publishing. On the one hand, that's good because it means the scientists don't have to worry about that, right? Somebody else's job to handle the publication process and the minutia, right, of all of that. But those companies have to make money. And so what that means is that oftentimes published scientific information is not available to the general public. It is inaccessible, or the general public has to pay for it. You have to pay by, if you want to read a research article that's published in a journal by the publisher Elsevier, they might force you to pay $30 to read that article. Never, ever, ever do that, especially because you're a college student, which means you have access to most of that scientific material as part of your payment to Georgia State. They pay, the university and the library system pays the publishers for access to this information. So you have access to databases in the GSU library. The largest one for psychology is called PsycInfo. And you can search there by topic. You can search there by author, by journal, by date, all kinds of things to find the published scientific information that you need. And these searches will return empirical articles, review articles, full-length books, and edited chapter volumes. Now, there is a movement within the academic community to make science open, right? To make it without barriers to entry and paywalls. This is a growing movement. It has some success. Obviously, publishers aren't really in love with this because it means it's going to impact their bottom line. But many, many scientists are sort of fighting against that payment process. But this presents problems in and of itself because publishing takes money. You have to have editors and publishers and IT people. You have to pay people to do this job, and so the source of funding for that publication can sometimes be difficult to achieve. But there is a large movement in the academic community to push away from scientific material being hidden behind paywalls and have it be fully open access to anyone who needs it or wants it. Now, there is a caveat to that. In the United States, and I believe this is the case in most countries around the world that are conducting serious scientific work, if the government funds research, it is freely available to the people, whether it's posted on maybe the CDC's website, the NIH, which is the National Institutes of Health, the NSF, the National Science Foundation, NASA, right? These large governmental organizations that fund and oversee research. If tax dollars are contributed to a research finding, it by law must be made publicly available on one of those places. So if your tax dollars helped fund something, you can always get access to it. But not all research is funded by tax dollars and government grants. Some of it's private grants. And so some of that stuff is behind paywalls. One way to get around that, and one really good alternative for searching for these scientific sources, is Google Scholar. If you just Google Scholar, what will come up is a sort of special search engine that's within the Google system. And when you search something in Google Scholar, you are only going to get scholarly material that's available on the internet. So for example, let's stick with the example, bilingual development, language development. So if you just went to regular Google and you typed in bilingual language development, you would get some scientific results, but you're also going to get non-scientific results. You're going to get journalism. You're going to get someone's blog. You're going to get Facebook pages and groups about bilingualism, right? You're going to get all kinds of stuff because it's just a general Google search. Versus if you did that same search, bilingual language development, in Google Scholar, it will only return scientific material. You're not going to get journalism. You're not going to get blogs. You're not going to get Facebook pages and things like that. So this is a nice way to try and find materials as well. Oftentimes there will be a PDF linked to it. Oftentimes publishers allow researchers to post and share PDFs of their preprints or their published materials on their personal website. So if a researcher has their own website or their lab has a website, you can find their publications there, and that will often come up on Google Scholar. It's a nice way to get around the paywall if you don't have access to these databases. Okay, let's talk about reading an empirical journal article. Empirical journal articles are written in APA style. APA style for empirical articles has very strict rules about the organization, titles, headings of different sections of the article, and what information goes in those sections. Scientific writing in general is less flexible. It has more rules and regulations and prescriptions than things like MLA or Chicago style writing. And so let's break down, especially since you are going to be reading some empirical journal articles this semester, let's take a few minutes to break down the different sections that you will typically find and what goes into each section. So the analogy that I like to use for the structure of an empirical journal article is an hourglass. So if we think about the wide parts of the hourglass as being places where we engage in general discussions and conclusions, right? Broader, this is the forest. And as the hourglass thins, information gets more detailed and more specific. So the major components of an empirical journal article are the introduction, method, results, and discussion sections. We also have what's known as an abstract, which is like a 300-word summary of the article. And we have, of course, our citations or reference section. So let's take each of these in turn, keeping in mind that the introduction and the discussion are going to be the sort of most theoretically broad sections, and then method and results are more detail oriented. Sorry, I thought I had a slide about abstracts. I can talk about them super quickly here. Again, the abstract is what you might call an executive summary of the article, usually around 250, 300, 400 words long. It's a long paragraph that summarizes the empirical journal article from start to finish. Abstracts are your best friend when you are doing a search for these articles. So if you're interested in verb learning in young childhood of bilingual children, so we're interested in how bilingual children learn verbs between the ages of 2 and 5, let's say. That's really, really specific. And there's going to be a good bit of research on that, but not everything that comes up in a search is going to be relevant. So what you can do is you can spend 5 minutes reading the abstract, and that will give you a summary of the article, and it will tell you, is this article relevant to my research topic or not? Do I need to take the time to read the full article, or can I just discard it because that's not really what I was looking for anyway, right? So your abstract is sort of the place where you can either accept or reject whether or not this article is relevant to your question. And it will save you a lot of time because you don't want to spend an hour, 2 hours reading the full article only to find out that it's not relevant for your paper or your question. So abstracts are your best friend when you're trying to sort of parse out what's relevant and what's not relevant for your particular, desires and needs. In the introduction section, which is the first sort of main section of the paper, we're really, really broad here because the purpose of the introduction is to introduce the major ideas, the major theories, and the previous findings in this given area of research. Basically, what are the concepts and previous findings that the reader needs to know in order to understand your experiment, right? What's the background information? The method section gets more specific. This is the recipe for your experiment. The introduction section is typically going to end with a hypothesis statement, right? So here's all the stuff that's been previously done. Here's our research question, and here's what we think is going to happen. And then the method section explains what the researchers did. It's the recipe for their specific experiment. There are 3 general sections for a method section, subsections for a method section. Participants, so who were our participants? Where did they come from? How did we get them? How many of them were men and women? How old were they? What was their racial makeup? Right? Were they college students? All those sorts of things. Who did we do this experiment on? Next, the experimenters will explain their materials. So what did they use? Was this experiment done on computers? If so, what kind of computers? What programs were they running? What measurement tools did they use? Right? What surveys did they use? What technology did they use? Did they use an fMRI machine? If so, what kind of fMRI machine? Right? All those sorts of details about the physical materials that were used for the experiment. And then lastly, the procedures. How, right? How did they do the experiment? Were participants in the lab for 30 minutes? Were they in the lab for 6 hours? What sequence of events occurred for each participant? Because ideally, you keep things as similar as possible unless you're actively manipulating something. So what sequence of events occurred? Did the participants have to come back for a second session? If so, what amount of time lapse was there between session 1 and session 2? So participants tells us who we did things with, materials tell us what we used, and procedures tell us how, right? How did the experiment happen? Ideally, if you put all of that together, then any scientist in the world with the appropriate access to materials, could redo your experiment. They could replicate your experiment perfectly, right? Just like you do with cooking with a recipe. Results. This is pretty straightforward. What data were collected, what data analyses were done. You'll see analyses and data presented in tables, in graphs, and figures, right? Visualized in certain ways to help make drawing conclusions easier. So basically, what were the results? What were the outcomes of this experiment? Importantly, the results section will not include interpretation of the data. It's just the presentation of the data themselves, right? Here are the data. Lastly, the discussion section. This is where you sort of tie a bow on the experiment and discuss what it means. How should we interpret these findings? Why is this important? Does it change anything about our understanding of bilingual verb learning, right? Can this apply to helping us teach bilingual children who are struggling with language learning? Does this need to inform public school teachers? Does this need to inform parents? Does this require us to update or augment a theory? And then lastly, where does this leave us for future research? What new questions do we now have? What new areas can we push into now that we have understood this particular finding? So that's the sort of world of science publishing. Of course, you can consume scientific material in non-scholarly avenues. You can buy what we call trade books, TRADE, which are typically books written by scientists themselves or science journalists who are trying to take a bunch of science and make it digestible to the broader population. So these books are freely available, right? Like on Amazon or in bookstores. And they're available for purchase through retail. Some maybe famous examples that you might have heard about of trade books. People like Steven Pinker. He's actually a linguist, funnily enough, who's gone on to really have a successful career in science writing for the general population. There's recently a new book published. Hold on, you're going to give me 2 seconds to Google the name of the book. It's by Carl Bergstrom, who's an epidemiologist. Sorry, give me one more second. Calling Bullshit, right? So by Carl Bergstrom and someone else. He's a data analyst and epidemiologist. He's an academic. And he wrote a book basically to help people understand how to be fluent in science, how to be scientifically literate. Right? So he takes our understanding of data and science and is trying to convey sort of the general concepts to the general public, right? And it's meant for, your average everyday person to read. So when you're looking at these retail books, you want to look for something written by an expert in the field or by someone like a journalist who spends a lot of time talking with or interviewing experts in the field. You want something that has an extensive reference or citation section so that you know it is founded upon actual science. And then you want to generally avoid books that make outrageous claims, right? Outrageous claims are just that. They're outrageous, right? So maybe a book titled 12 easy steps to become a genius, right? Probably bullshit, right? They're probably just trying to get you to buy the book. It's unlikely that that is going to be founded in really good science. Or if it is founded in good science, it's going to really mess it up and extrapolate too far from that science. Wikis. So obviously the best example is Wikipedia. You know, people complain often in academia about Wikipedia, but it tends to be from the perspective of students using Wikipedia as a citation. Things like Wikipedia are not appropriate for academic citations in professional or school work. It's not appropriate. But wikis are a good place to learn a little bit about large areas of information, especially wikis that are moderated well and updated well. I would never say that you should use Wikipedia in an academic or professional work, but it's not a terrible idea if you find yourself having to write a paper about something that you have zero knowledge about. It's not a terrible place to start with just a nice Wikipedia search to kind of get the lay of the land, right? What sorts of things are out there? What are some definitions of key terms? Because wikis are generally written for consumption by the broad population. They're easy to read and digest. They tend to be kind of short summary materials. You can't completely trust them because often they're open sourced and edited by anyone. But the better ones, like Wikipedia, are monitored pretty well. And in general, you can trust the information, especially if it's cited within the Wikipedia page. So again, it's never appropriate as an actual academic source, but it is a halfway decent place to start learning about something that you know absolutely nothing about. Right? It's not the worst place to start. And of course, you can learn about science from the popular press, from news. Not all of these are created equally, especially in the age of the internet. There are many, many news outlets and organizations that are overly hyperbolic because they're trying to just maximize their views or their reads, right? In the modern internet economy, how do you make money? Clicks, right? That's where we get the term clickbait. So lots of articles and headlines are written such that they get you to click on them. And then the information in the article doesn't quite match up with the headline itself. And the publication is just trying to get you to click or read to boost their numbers so that they can increase ad revenue, right? That's a real danger in the modern internet age of information. Also, some news organizations are going to actively lie and manipulate to push a particular viewpoint or to drum up interest, right, so that they can get more views and reads and thus make more money. So you have to be careful about consuming science in the popular media, the popular press, because of purposeful ideological slants and manipulation of information to try and drum up, something maybe going viral so that they can make money off of it. However, many popular press organizations are perfectly competent and journalistic and neutral and honest sources of information. Many of them hire science journalists who dedicate their lives to trying to inform the populace about new and upcoming scientific findings. The trouble is, of course, telling the good ones from the bad ones. That's often a source of discontent as well as misinformation among many people. I can't give you any obvious or hard and fast answers about what to trust or who to trust. That's where you becoming a scientifically literate member of the populace, is important. The ball is in your court to do your due diligence and figure out what things are appropriate and which things are inappropriate. In general, in my personal opinion, I find these four news sources to be generally very reliable, to be generally neutral, unless, of course, there is a piece that's explicitly labeled as an opinion piece, right? So let's take the New York Times, for example. They generally do a very good job of reporting the news and being neutral and providing critical analysis of actual reliable information and scientific findings. But the New York Times also has opinion columns where a person, right, writes an article that is expressing their opinion. And that's fine. There's nothing wrong with that. And the New York Times labels it as opinion. And so it's fine. We all understand that it's an opinion. People are allowed to have opinions. The problem is when you try and pass off your opinion as just fact or reality or critical thought for everyone. So I find these four sources: NPR, New York Times, Washington Post. BBC is often really good for a non-American perspective. They're of course based out of Britain, and so I oftentimes find that they can provide some interesting and helpful analysis from maybe a different perspective that's not so sort of in the muck and mire of the United States. So if you're looking for good science journalism, I would say start with these four sources. That's my opinion. There are others, and there are other. These are not the only good sources, in my opinion. They're just four sort of general, broad places where I would start my search if I'm looking for popular press and journalism. So that's it for part 2 of chapter 2. We're all finished. Make sure that you complete the workshop for chapter 2, and I will see you next time for chapter 3. Thanks, everybody.